Hello, and welcome to another video on computer algebra. This time I'm going to talk about semantics a little bit and then give some basic examples of expression trees. So semantics, that is, what do things mean? I'm first going to talk about what does code mean, because code and math have a lot in common. So what does code mean? For example, let's suppose we have a computer program and it says print hello world. What does this program mean? One thing that it could be is an instruction to print hello world. To the screen. Another thing, if this is a different language, it could be an expression or an instruction to generate some binary code that prints hello world. Some languages are interpreted, so you just run them on some code and the code executes. Other programs are compiled, and in that case, the program doesn't run when you invoke it. It actually creates an executable that's run. So this could be an instruction to generate binary code that prints hello world. What else could this be? Another thing, if this is a language where this doesn't mean anything, like maybe you're in a language where printing is not spelled using the word print. Maybe you're writing, I don't know, JavaScript or something. Then this would be a syntax error. Or actually, this would be just fine in JavaScript, but some other language. Anyway, there are languages, like I will use JavaScript as an example. This is a perfectly fine JavaScript program, assuming you've defined the function print. But there's, in JavaScript, semicolons at the ends of commands are optional, but they are recommended. So another thing that a program can be is the set of all warnings that it generates. So a program, this program could be a warning expected semicolon. So a program, you don't have to execute it. You can also look at it and say, does this make sense? What could be some problems with this code? So a program can be instructions to do what the program says. It can be, or it can be the set of all warnings. So now let's talk about math. What does a mathematical expression mean? Let's say we have an expression like 3 plus 4 times 5. What does this mean? Well, one thing that it means is it's an instruction to produce a number. Just like this program is an instruction to do something, this is an instruction to produce a number. And this produces 23. So can be an instruction to produce a number. But not all mathematical expressions are like this. Like, for instance, what about 10 to the 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 10? I think, okay, that's plenty. There aren't enough atoms in the universe to represent this number if you wrote it all out. So an expression is not necessarily an instruction to produce a number. It could also be like this. We can look at this and know what it means. It's just huge. So another thing that an instruction can be is a data structure. An expression can be as a data structure. That you can pattern match. So, for instance, we can say this is definitely greater than this by some, like, you can prove that yourself. That's an exercise to the viewer. Yeah, we can prove that easily by just pattern matching this thing and looking at it. But it's not it is an instruction to produce a number, but we can't possibly follow that instruction. It's finite, but there's not enough matter in the universe to do that. Now, another example of a mathematical expression. Let's take this. Sum from n equals 0 to infinity of 1 over n factorial. This is the famous number e, Euler's constant. But this is an infinite decimal. This is an infinite decimal, so you can't ever compute the whole thing. This is clearly a finite expression. Like, look, this has 1, 2, 3, 4, 5, 6, 7, 8, 9 symbols in it. 9-ish symbols. So it's a finite expression. It's definitely a small data structure that you can pattern match and work with. But if you think about it as an instruction to produce a number, you'll never finish. It's an infinite, non-repeating decimal. This is e. So another thing that an expression can be is, but you can produce digit after digit. Like we know e equals 2 point, I don't remember. I don't even, is it 7 or 1? I think it might be 1, 7. I don't remember. Anyway, we can produce digit after digit. So another thing an expression can be is instructions to produce a series of digits. I'll say a sequence of digits. Sequence. And this, by the way, is what people mean when they say a number is computable. Like e is computable and pi is computable and 5 is computable. This means that you can make a program that outputs the nth digit of the number for any number n. And yeah, so that's another thing that an expression can be. And there's more types of things in mathematics than expressions. So expressions are numbers. And there's more types of things. Like there can also be statements that can be true or false. And specifically, I'll talk about equalities. So what does an equality mean? One last thing. What does an equality mean? Well, one thing that it can mean, let's say we have an equality like for all a plus b equals b plus a. So this is clearly true. An equality, this is true. We can say an equality is a statement that can be true or false. That's one thing that it is. And an example of another equality that we can think about is there exists an A such that A plus 1 equals A. And this is clearly false. There is no A where you add, except infinity, maybe. Yeah, so maybe this is sometimes true. But anyway, and one thing that an equality is a statement that can be true or false. Another thing that an equality can be is an instruction for rewriting expressions. And I'll clarify that momentarily. So, what I mean by this is basically what you would do on paper. Anytime in math class that you are deriving something, on paper you use an equality as an instruction for rewriting something. So, let's say you have 3 plus 4. You can use this as an instruction for rewriting 3 plus 4. And then you can say this equals 4 plus 3. And then you can say, now I'm done with that. I have 4 plus 3 now. So you can use equalities as instructions for rewriting expressions. So now that we have these things in mind and some different ways of looking at the semantics of things or interpreting what they mean, I will just quickly demonstrate some quick expression trees. So how does the computer understand this when you type it in? Or even a program like this one. How does the computer interpret that and work with it? Well, it creates an expression tree for programs and for math, all of that stuff. If we have an expression like 3 plus 4 times 5, the computer turns that into a data structure that it can understand, and that becomes an expression tree that looks like this. It's got a plus, and then the two things that you're adding are 3 and 4 times 5. And the 4 times 5 is a multiplication, and the two things that you're multiplying are 4 and 5. So this is sort of like what an expression tree looks like. I can talk about how this thing would be parsed, but that's not really necessary right now. I'll just sort of like briefly summarize. This thing, the computer would look at this and say, kind of look through this thing and say, the lowest precedence operator is a plus, so I'm going to say that at the highest level, this expression is the sum of two things. And one of those things is the 3, which goes down there, and the other thing is the rest, which is 4 times 5. Then it recursively looks at this and says, oh, this has an operation in it, and that operation is times. And the two things that are multiplied are 4 and 5. So that produces this bit. So there's an expression tree. And then if you have an equality, like for all A and for all B, A plus B equals B plus A, you can write this. This is a way that you can write a rewrite rule. So any rewrite rule, looking at this second interpretation of these things, we have a statement that can be true or false, which is one thing that is. And it's also an instruction for rewriting expressions. So looking at it that second way, you can write this as an expression tree, plus A, B, plus B, and A. That's the expression tree for this thing. And you can say, okay, so it's got an equals note at the top, and then on the left-hand side, there's one thing, and on the right-hand side, there's another thing. So, and then these things are equal, which means that they can be swapped for each other. And you can use this to do things like rewrite 3 plus 4 times 5. So if you have 3 plus 4 times 5 and you apply this rule to it, what will happen is the left-hand side of the rule will be pattern matched against the expression tree that you've got. And what that will give you is the computer will look at the top node of each of these trees, and it'll say, oh, let's match these together. and it'll say, oh, good, they're both plus. That means these match. Then the next thing the computer will do is go down the left-hand side of these operators, and it'll say, okay, we have a variable a in the rule, and in the expression we have the number 3. So it'll say, okay, let's set a equals 3. Then it'll go down the right-hand side and it'll say, okay, we've got this in the expression and this in the rule. We've got 4 times 5 in the expression and b in the rewrite rule. So then it'll say, okay, let's set b equals 4 times 5. So then it's got these definitions, a equals 3 and b equals 4 times 5, and it's done looking at these trees. So then it moves over to the right-hand side of the rewrite rule and substitutes everything in. So it'll create a plus node, first of all. It'll say we've got something plus something, and then it'll look at the left-hand side, and that's got b, which we know is 4 times 5, plus a on the right-hand side, which we know is 3. So this will be what happens when you rewrite 3 plus 4 times 5 using this rewrite rule. You've now got 4 times 5 plus 3. So that's sort of like another way of looking at expressions. Other than this being an instruction for computing a number, you can look at this as a data structure. And you can also look at the rewrite rule as a data structure that tells you how to transform another data structure. So that's sort of like the basics of how computer algebra works. It's expression trees, and then there are algorithms that look at the expression trees and transform them by pattern matching parts of them and moving those parts around. So that's about all. I will, we'll see. I'll have to figure out what I want to do next. See you next time.